Thank you for to APWA for allowing me to do the presentation today. I am just going to give a very surface level introduction to pavement preservation. So the idea of trying to extend $1 on a budget for creating a better transportation system, your asphalt roads within your city, your county, etc. So just trying to get a little bit more out of your budget. Okay, so let's start with actually defining what we're looking at. We're looking at pavement preservation. The word preserve, what we're trying to do is to keep something in good condition. You want to keep it safe from harm, prevent it from decaying, and overall maintaining it. So a pavement preservation standpoint, that's exactly what we're trying to do with your pavements. We don't want to let them go to waste and then have to spend a lot of money on the back end in order to repair them. So a good example of trying to equate something that you can tangibly get a feeling for on pavement preservation is when you look at a house. You have some houses that are just really broken down. You're really not sure if you actually want to walk into the house. The structural integrity is a little bit questionable. You start looking at it going, okay, if I need to do something to this house to make it actually worthwhile to live in, you're looking at a full reconstruction, rehabilitation. You're either going to start over, just plow it down, or do a major reconstruction. So this is the equivalent to what you would think of as starting over. You're going to do a full rehabilitation. You're going to mill your pavement all the way out and then rebuild from the bottom up. Or if you're going to do a major reconstruction, maybe mill all the way through all the asphalt layers and then replace them to get a fresh start. The preservation portion of it is something that, you have already a good structure. The house by itself, like in this picture, isn't too bad. You're looking at it, you say, okay, well, I can work with that. If nothing was done, it would still have some life in it for a little while. But, you keep some new coats of paint on it, maybe keep the landscaping up to date, have that little bit of curb appeal. You start looking at it going, okay, well, it's basically a little bit of touch up here and there just to keep it updated and to make sure that nothing structurally is ever going to go bad. So that preservation part is just that. It's just trying to maintain something that is already good. For pavements, when we look at it, you're looking at something with what we call the curve. So what you're looking at currently is that red line. That's the life of the pavement. So it starts off brand new all the way to the top left, and it's going to start sloping down as the pavement ages, as it deteriorates, and as it goes through the life cycle of the natural pavement. What we want to try and do is what we're looking for is to try and get to the pavement before it actually gets down to this portion that's 75% life and lower. The lower on this curve, the more money you're going to have to put into it. If you can maintain it while it is still in this good range, spend a little bit less money, this curve kind of bounces back a little bit, and then it'll bounce back every single time you put a treatment on it. So the idea of spending a little bit less, a little bit sooner, will end up preserving your pavement, and it'll extend the overall life cycle of your pavement by several years. The asphalt deterioration curve, so if you take the line of the curve, the life cycle, when you look at it, you're going to end up having to look at it from the very, very beginning. There are treatments that you can do, where some of those treatments will go on almost 1 year after. And so what people would think of still as a brand new pavement. And it's kind of counterintuitive. You think, oh my gosh, I just paid all this money, I have a brand new pavement. Why do I need to pay somebody to go back out there and then do something to it again? Well, again, it's that maintenance. Why do we have to change our oil after 3,000 miles? We just bought a new car. You want to make sure that engine doesn't fail. So it's the same idea. we want to make sure that as this curve, as we start traveling down this curve, we do what we can to keep this portion of the curve as high as possible for as long as possible. So the further down we go, the more work we have to do in order to actually get this curve back up into this good range. And sometimes it's just going to take an entirely big job where you end up doing a full depth reclamation, or you mill off the asphalt pavement and replace it. And there are several other things in here that encapsulate what you would consider a full rehabilitation. The big terms for pavement preservation is the idea of it is going to be about applying the right treatment to the right place at the right time. So remember that curve, it's all about timing, but it's also about where, when, and what. So what does that mean? When is that right time? The very left over here, we have a pavement that was just constructed. Now remember, I did say that sometimes there are treatments that go down, and 1 year later you see somebody out there spraying down a treatment, and you're going, well, geez, they just made that. But this is more of the, oh, well, it's 1 year old, maybe we don't need to address it right away. It looks great, it's performing well. But then again, you got something that may have been out there for 12 years, never been touched. And you've got a lot of structural issues underneath, things that are happening and failures that are happening that cannot be just covered up and hope that if I just seal it off, that it won't continue on to deteriorate. So there's a happy medium right in between where your structure is still good. You don't have a lot of this really deep down cracking occurring. And it's not brand new where you feel like you just kind of wasted a lot of money putting a new pavement in. So that right time is going to end up being maybe just as it starts to age enough, but not too much to the point where you want to say, okay, well, if I have a budget that I can put in and it's going to cost me a third of the cost of waiting and spending a lot more money later on, why not do that? So if I can pay $2 for the treatment for square yard here, then compared to something where I am going to have to pay $8 a square yard, then why would you end up not treating it beforehand and extend the life out longer than you can? There's a website that is organized or put up by the Pavement Preservation and Recycling Alliance. It's the PPRA. They have a fantastic resource in that website that allows you to look at a cross-section of a pavement. If you scroll over that pavement and you go through these sections, you can tell the kind of distresses that you're looking at. So something that's relatively new, something that's a little superficial, something that starts with kind of going into the structure portion of the asphalt, and then something that you really got to do some work on in order to get it back. As you scroll through this, it'll show you which treatment it actually applies to. So if you're over here for that surface treatment, it will highlight the surface treatments that are appropriate in order to address that kind of distress that you're seeing on your pavement. The website is a great resource to just kind of get a feeling for, hey, what are the different treatments? What do I need? I will reference a lot of the kind of the finer points of what they have. And there's a very good group that runs that, and a lot of information coming out of there. So overall, pavement preservation compared to hot mix asphalt, what is really different? I mean, you still got aggregates, you still got asphalt. Back and forth, they're both the same material-wise. Right? So at the end of the day, we're dealing with the same thing. The equipment is relatively the same. You still got a paver in a lot of cases. You still got tack trucks or distributors that are putting down the emulsions. You still got rock spreaders or rock trucks that come by. So the equipment is all familiar. If you're a hot mix person, that you're familiar with that process, the equipment is not much different. What is different, and the things that most people are going to be a little bit, have to research a little bit, is going to be about the material testing. So the materials, as far as the requirements on the materials, will be different than what is required on a hot mix asphalt. So we're looking more at emulsified asphalt, so whether it's cationic or anionic. So you're looking at these two groupings, so the emulsions, and you're looking at more one size or smaller types of aggregates with some mineral filler. So let's look at the emulsion testing. So there's a lot of things that are out there. Emulsions come in all numbers and letters, and they come through, and really, what are you looking for? If you're an owner, what are you looking for? You're looking for something much different than what a contractor is looking for. Contractor, I want to know, can I get it, put it in my distributor? Will it come out of the distributor when I ask it to? And will it go down at the rate that I need it to go down? So these are the tests that you're looking at. A very general idea of them. You're looking for handling tests, storage stability. Will it actually turn around and be sludge by the time I actually try to spray it on the road? Those are the kinds of things when you get your COA that you want to make sure, hey, it's passing spec. As an owner, this portion of the emulsion is really not that much of a concern, other than the fact that if it goes south, it's going to be a contractor's headache. So it's in the best interest of the contractor to keep that portion of it in mind. From the owner quality standpoint, you're looking at something of how much asphalt is going to be left over. Right? So you want to know, but on the residue, from distillation, what is going to be left? That's the asphalt. Then what are the properties of that actual asphalt? Because at the end of the day, when all that water evaporates out of the emulsion, that's all we have in order to make sure that the pavement preservation treatment is actually going to be working. In 2008, AASHTO developed an emulsion task force. So part of this was to, as part of the MAP 21 movement for the FHWA, the state DOTs were allowed to use federal funding for pavement preservation. So that was big. Before, there was a lot of states that had to just use state funds. They were looking at their budgets, trying to go, oh, well, I know I can stretch the dollar here and there, but okay, well, I can only get federal funds on my big jobs. Well, with the push being able to kind of open that up, and the idea of the feds seeing the value in the preservation, that was able to get more funds into the preservation, more exposure of those treatments on a bigger level. The task force itself comprised of several different entities between the Federal Highway Administration, several national groups that involve, like the International Slurry and Surfacing Association. So you're looking at groups that are very well educated on the ideas of these types of materials, the emulsions, the aggregate, the interaction between them, knowing how that these preservation treatments should be used, and then trying to coordinate with the industries like the DOTs, the contractors, the suppliers, and even the researchers that are doing some of the future work to create a system that makes sense for everyone. Prior to the task force, there were no unified systems or unified specifications and test methods for the pavement preservations. Every state, every county, every city had their own little tricks, and everybody had their own specifications. So the idea behind this is that this group will come together, be able to look at these types of treatments, and then create different material standards, design practices, and some standardized test methods as well. There is some research going into the different types of treatments. For instance, the cold recycled mixtures. There's a research being done on a national level to properly address them in the field, how to accept them, how to be able to tell whether or not it is cured and ready to go. So it could only end up being a good thing in the sense that if we're all on the same page, we're getting a more uniform product. We're getting something that is across the board, everyone understands. You can talk from one state to the next, or one city or county to the next, and people understand what you're trying to do. Just being able to educate continuously with the more dollars that are out there in order to be able to use towards these projects, you can educate the next generation of your staff, the consulting staff, the DOT staff, even the federal staff, to be able to use more of these properly and extend a budget when, especially in these times when the budgets are somewhat questionable or just an unknown. So currently, we're looking at agencies that have already adopted some of the specs, and they're in place. A lot of those states are places that they own 100% of their transportation system or their pavement system, where they are responsible for every inch of pavement that goes out onto the in the state. You will see a lot of the preservation techniques being utilized in those kinds of situations because they have a very tough job of trying to stretch one budget over an entire state. So those states are pushing to advance these type of specifications and material test methods to a national standard where they could possibly go to the next state over and get a guarantee that you're going to get the same material. So they're streamlining the specifications can only make the quality of the material better, the quality of the actual designs better, making sure that everybody's consistent. We're going through the same processes, and that emulsion grades, like I said, can be purchased at any state. You know what it's supposed to be. If someone orders an emulsion that says a CRS1, we know that CRS1 is going to be consistent from Florida to Georgia to Alabama, etc.
Tanya, Mike, this is probably a good place for a question.
Overall, this is a short list of preventative treatments that you can see. We are going to focus on a couple of the treatments that are in this column. So the surface treatments is anything that it just exactly like it says, it's lying on the surface. You're looking at something that as a pre-treatment, that's something that goes on before something else. So the tack coat, prime coat, something that goes on before possibly a thin lift overlay. Recycling and reclamation, all of these, you can do it either on site, you can do some of them in the plant. You're looking at different types of processes in which you can actually use the different types of methods in order to get a better product, but for maybe a little bit cheaper cost and get a little bit of life out of it until you get that bigger budget. And then there's also deeper down, you need base treatments as well. But again, primarily when we're looking at preventative treatments as far as pavement preservation, especially in Florida, the primary ones are the surface treatments. Full depth reclamation, you will see a lot in Florida, but it is still not a surface treatment. It is something that you have to mill all the way down to the base in order to be able to do the process.
All right.
Mike, is there a poll question?
Yeah, let's launch this first one here. What is pavement preservation? All right, just launched it. I strongly recommend everybody vote because it kind of. Oh, am I? No, I shouldn't be. Can you hear me?
I don't think Tanya can hear us, Mike, but I can hear you.
Okay.
I can hear you.
All right, I recommend everybody vote because when I sent it to National, they wanted your name's going to show up on these polls that you were paying attention and listening. Doesn't matter if you get the right answer or not.
Okay,
but
Mike, I can't hear you. I don't know if anybody else can.
Yeah, everybody's. Molly said she can hear me. Althea, Are you there?
I can hear you, Mike.
Okay.
I can hear you, Mike.
All the attendees say they can hear me.
Okay.
Okay.
All right, so I'll end the polling now. We got 100%. Great. Share the results. And everybody pick applying the right treatment to the right place at the right time. I think that's
All
correct, right? Okay,
That is correct.
very good. You can go back.
And I don't know what happened there.
Is Tanya there?
I am here. Can you still hear me?
We can now, yes.
Okay. Okay, so the idea of the preservation treatments, so again, we're going to go through some surface treatments. We're going to primarily be looking at the, see if I can get it going. There we go. The crack sealing process, the asphalt rejuvenation, microsurfacing, and thin lift HMAs, or hot mix asphalt. So these are the four that I picked in order to kind of really talk about, because it's what we've seen in Florida being used the most. There are chip seals and there are some microsurfacing jobs that are going down. There's not enough time to talk about every single one of them. So I picked, 4 of them out of the hat, and here we are. So crack sealing and filling, you're looking at exactly the way it sounds. You are taking a hot mix asphalt, a hot asphalt, a very sticky, probably modified binder that you're going to take and place inside the cracks. So when you start looking at your pavement and you start seeing that aging happen, you have some cracking forming, it is possible to go out and fill those cracks. You want to reduce any of the water that's coming in through those cracks. Water is what we consider the devil or the enemy of the asphalt pavement. Anything that you can do to prevent water from going into the pavement is going to elongate the life cycle of your pavement. So if you can seal it off, the longer that you'll end up being able to use the pavement. So you're going to reduce the water infiltration, prevent the intrusion of, excuse me, of anything else that is detrimental, like clays or any type of deleterious materials is what we consider them, root systems that could possibly kind of grow legs and be able to tear apart your pavement. You want to provide support to the adjacent pavement, meaning you don't want to just kind of put a little bit of material in there. You want to actually fill that crack. You do not want to leave any of those gaps, because then you're kind of defeating the purpose of actually sealing it off from that water and any other materials. A couple of things that you got to think about, though, when you're looking at these cracks, you want to make sure that they are fully prepared properly prior to filling them. They need to be clean and dry. Asphalt does not stick to wet things very well. So if you end up putting something in where there is a lot of water, you will end up having debonding issues. The bonding agent in the asphalt will not actually work. You can route the crack out, make sure you have some clean sides, make sure that the asphalt has something to grab onto. You can cutting the crack allows more filler to be used within the actual bond in the asphalt, and allows better control of the channel size. So you don't have to worry about, do I put a little bit here and then I gotta pour more, a little bit and then more. So it gets a uniform size of the channel in the cracking in order to be able to get a very clean fill as you're putting the material in. There are several different types of materials that are used for crack filling and sealing. There's a lot of different types of modified emulsions that you can use. This is a very rough cut of some of the list of sealers that you can use in order to fill some cracks, get some of those edges out of the way, excuse me, and prevent some of that water intrusion. A lot of the ones that you will see are just the polymer modified ones or the rubber modified emulsions are going to be highly used in this type of process. The innovations as far as the crack sealing goes, there's a guidance on material selection. They are coming out now. Again, there's a part of the group with the task group for AASHTO. They're coming out with some guidance on creating a sealant grade. So just if you're familiar with hot mix asphalt, the asphalt itself has a performance grade. It's, for instance, we use a PG 67-22 in your asphalt. Well, this will have a sealant grade. And so this is to try and put that right material in the right place. So not only does the treatment have to be in the right place in the right time, it has to have the right material as well. So a good candidate for sealing, you want to make sure that it's new or recently rehabbed surface. So again, the sealing's not going to add any structure. It's not going to add anything of value as far as the soundness of the pavement, other than to try and prohibit the crack from continuing to wander and to continue to grow outward. You don't want to have a lot of secondary cracking. I mean, if you think of a line, or think of a branch, if it has a lot of outlying twigs and smaller branches coming off of it, it's probably not a good candidate to try and do a lot of crack filling on. Because if you had to route or cut every single one of those little cracks, you may as well just go out and draw on your pavement in a black squiggly line. It's better to do a different treatment for something like that. You want to be able to have little to no raveling at the face of the crack, meaning you don't want any of that material starting to come off of the pavement around it. You want to be a fairly clean line when you're going through. Again, crack sealing does not add any support to the pavement, so you need to make sure that you're structurally sound. That base is good, the pavement itself is good, and is little to no structural deterioration. As a whole, when you're looking at crack filling, you say, well, if I do this, will it do its job? What are you looking for? You're looking for it to slow down or stop moisture damage. You're looking for it to stop the cracking, maybe reduce some of the roughness so you don't have that disparity in the level. And you're looking to maybe reduce some of that rutting. I mean, some of it is, the pavement is moving a little bit because of those cracks. Sealing it may be able to bond those two sections together somewhat. You're not looking at to try and completely seal it off, but you're looking to try and make sure that it's not going to continue to separate. If you have some crack sealing that you have to fill a lot with and you have a lot of material in the different cracks, you may develop some extra roughness. So you just got to be careful of how much you put in and have a company that knows that system to do it. Friction-wise, friction is primarily because it's straight asphalt and some filler or some polymer. There is no frictional value to crack filling. It is primarily just an asphalt binder, a filled binder, in which it will then become slick. So your crack itself, hopefully, is not going to be the width of your tire, so you don't have to worry about it being super, super slick in hydroplaning. But you will end up having some slick spots if you have some heavy cracking areas that you filled. So just a note of caution. Some best practices as you're doing some of your crack filling, before you apply any of the treatment, make sure that your road is cleaned with a power broom or sweeper, or fully flushed out. Having a dry road is more important than excuse me, than a pavement temperature, or the air or the pavement temperature. Meaning, if it is scorching hot, but in the you had a choice of either doing it now, when it's in the middle of summer, or you have a choice of doing it when it's just kind of, you know, barely damp after a light rain, but temperature's looking good. Do it when it's dry. If you do not have a dry pavement, asphalt will not stick to it. And then you could probably go out there. There are times where you can peel up the entire crack that you just filled. So just be err on the side of dry over air pavement temperature. The temperatures of the pavement will come down and it will seat and it will harden up. It's just a matter of giving it time. But if it is wet, it will never stick. The melter tanks that end up feeding the wands that fill the cracks, you want to make sure that that is no less than 3/4 full to make sure that you have a good temperature. You want a good bulk quantity in order to maintain a constant temperature. So the next pavement treatment that we're going to talk about is something still superficial. So you're talking very, very on top of that curve. We're looking at a pavement surface preservation technique that is sometimes applied as early as 1 year after construction, and then consequently applied every 3 to 5 years afterwards. This process alone is highly recommended, and it is getting more recognition as time goes by, but it's been done for quite a long time. We're looking at restoring that chemical property, or the consistency of the asphalt layer that's on the very, very top. The thing with asphalt is that it is exposed to the sun, it's exposed to the water, and then the traffic on top of it. That top portion of it gets aged quickly. And once it starts aging, it becomes more brittle. That's when we start seeing cracking. So if you can maintain a maintenance program in which you try to keep it, keep it young. So in the terms of relation, you're looking at something where if you're trying to keep, like, I don't know, I'm a girl, so you look at a face cream, trying to keep your face looking young, trying to reduce the amount of wrinkles or anything else that show up along the way. You want to think of it as that. Keep it rejuvenated, keep it young looking, making sure that you're going to get the most out of your pavement while the structure is still sound. The asphalt rejuvenation process itself, it penetrates the top 3/8 of the asphalt pavement to reduce the binder viscosity. So remember, viscosity is the resistance to flow. The higher the viscosity, the slower it'll flow. And so what we want to do is make it less viscous. More viscous indicates an aging, less viscous indicates that it is younger. Does not provide any structural improvement. What you're looking at on the right, the distributor truck, is spraying an asphalt rejuvenator, and that's all it is. It's just an emulsion that gets sprayed on top of the pavement. You're going to end up seeing it kind of penetrate the top 3/8 of the pavement and that asphalt on that top layer, and try to keep it young. Typical life extension, you're looking at about 5 years per every time you go out and treat it. So if you look at brand new pavement, you estimate 12 years. If you go out year 1, just to make sure that that brand new asphalt stays young, and then every 3 to 5 years after that, every time, think of your life cycle pushing out another 4 to 5 years. You went from 12 years, now I'm at another 17 years, etc. And so you keep pushing it out to almost brand new every time you do it. So what you're looking at here is a pavement that had been treated. The new pavement, excuse me, the new pavement in 1997 was treated with reclamite, and it was, so they sealed it against the water absorption. So that's that light gray section that you're seeing towards the top right the picture. And then the new pavement in 1997, same time, they left untreated. You can see some of the damage. You can see some of the cracking that was already there, or that has developed since. And you're looking at the difference between a pavement that had a very good asphalt because of the treatment. We're looking at 4 years later, and it has maintained its youthful look. You're looking at the pavement that's been untreated. You can tell it's holding water. You've got a lot of cracking. The cracks are starting to connect with each other, which then becomes more of an issue later on because it'll allow water into and under the base, or I'm sorry, under the pavement. So effectiveness as far as the actual treatment goes, you can see the damage between the untreated and the treated with the reclamite is much, much different. So you're looking at a treatment that's very cost effective, very quick to use, and something that is worthwhile and an investment, so you do not have to try to address it with a higher budget down the road. So let's look at the fundamental idea of asphalt rejuvenation. We're looking at the chemistry, so the nerd part of the asphalt rejuvenation. You have two parts, or the two main parts for components of the asphalt. You're looking at your asphaltenes and maltines, and then if you start thinking about the difference between them, you've got maltines, and which is kind of like the if you think of spaghetti and sauce. So the maltines are the sauce part. The asphaltenes, that's what forms when the pavement gets old and it starts becoming a little more rigid, a little more brittle, more susceptible to cracking. So you want to be able to get in there and get more sauce in there. So the asphalt rejuvenation process with that emulsion is doing exactly that. It's trying to replace that or bring that ratio between the maltines or the sauce and the spaghetti or the asphaltenes back to a mobile state. One of the good things is that a lot of these rejuvenation products now are also clear. So you're looking at no need to be able to have to go out and sandblast and then restripe some of your markings. And it is something that it's very easy to use. So you're looking at a lot of, these are just a couple of pictures to show the differences between treated and untreated pavements. And the idea of not having to do something extra other than get a distributor truck and spray it is pretty attractive. So the rejuvenation itself, you say, okay, well, good, you sprayed it. How do you prove that it actually worked? Well, for the last 50 years, visually, people have seen the difference. You saw the pictures that were shown on the differences between the distresses that develop over the years. The viscosity testing using a DSR, which is a binder dynamic shear rheometer test, looking at the difference between the original pavement and then after it has been treated. And then a couple of the more advanced ones, we're looking at the International Roughness Index and some 3D high resolution imaging. I would say the most common that was even adopted by the FAA was that second one. They take cores, they look at that top 3/8, and they compare the viscosities and the reduction.
Hi, Tanya, this is Mike. We're coming up about 10 minutes to 1. I know we started a little late. Some people have to leave at 1, but
Okay.
I just want to say that, I'll let you go ahead and finish. I see you're only at slide 3461, so I don't know how much longer we have, but
I will speed through them. How about that?
okay. And
if you have questions, you can ask.
we'll go ahead.
Okay.
We'll go ahead beyond 1 o'clock because we did start a little late. So those that can
Okay,
stay
sounds
with
good.
us, thanks. And
Yep.
I'll have the video available for anybody, for everybody.
Okay.
So, and whenever you're ready for the next poll, let me know.
You can do it now.
Okay. Let's launch number 2. Which of the following is not an example of a surface treatment? I get 71%. Can we hit 100% again? May have lost some people. Nope, we got 78%. I need 3 more. Are you out there?
There you go.
All right. Excellent. So we had 93% FDR, full depth reclamation. That was correct. Okay, go ahead.
All right, thanks. Okay, for the sake of time, I will try to get through the next sets a little bit quicker. Again, asphalt rejuvenation, you're looking primarily at just trying to keep that top layer young, but be careful because it is a top layer emulsion. Just watch your friction. Watch the friction values and make sure that it's going to wear off that top portion just to get the rock friction back. And come on. So microsurfacing was the next treatment that we were going to go through. This was developed in Germany. This was to be used on the Autobahn in order to repair some of the rutting. So they didn't want to do a whole repave because trying to get out on the Autobahn was just ridiculous to try and pave it while there was traffic out there. So trying to use the microsurfacing to fill in the wheel ruts was the idea behind this. It picked up in the United States around the 80s. It was basically an effective way to do the rutting treatments. The polymer modified asphalt emulsions, mineral aggregate, water, and some different additives. Microsurfacing is probably one of your more defined treatments, meaning the ISSA code gives you a full way to check and monitor a mixed design process and testing and quality control. Material-wise, again, typical mixing order, you're going to take your aggregate, you're going to stabilize with Portland cement, you're going to have some water, some individual additives for your mix design and your emulsion. So as far as the microsurfacing goes, emulsion materials are a big deal. It's one of the key things that make the microsurface work. You want to make sure that it's a quick set, so you'll see a QS cationic emulsion. A lot of times they're latex modified, and you can do cationic, anionic. I know a lot of them actually do mostly cationics. You're looking at mineral filler, which is a mixing aid. It's more or less to try and distribute that emulsion. If you were to use the wrong emulsion, you would know it. It will take forever to set. Your microsurfacing mix will sit there and it will never harden. The durability of it, you'll see kind of go very quickly as well. You'll see a lot of that rock not adhere to your emulsion, and it will start coming out off the pavement. Sometimes you also get delamination from the underlying layer as well. Overall, material testing, this is, like I said, is a little more defined on this type of treatment than some of the others. You end up having very specific tests to be run for a mix design process. Some that you don't ever see in a hot mix process. You're looking for wet track abrasion loss, some cohesion, just to make sure that that aggregate is sticking to the emulsion. And you're looking at some things that, so if you're thinking about doing a microsurfacing, you want to be able to know that the mix designer is conscious of these tests, looking at them, able to do them well, and get you some numbers that make sense. This is just a very fancy flowchart to say that there's a lot of stuff that goes into the actual microsurfacing mix design, and then it goes down with the emulsion, goes down on the road, and the chip spreader will actually bring the rock back over the top. Micro can be used in almost anywhere, parking areas, urban and residential streets and airports. You're also looking at some of a nice microsurface on a county road to maybe even used as a leveling course. Some places have even used it as as high of traffic areas as some of the interstates. So you got to think that's a pretty heavy duty mix if it was originally developed for an Autobahn in order to help rehab some of the rutting. Microsurfacing has been seen as far as the state highways and the interstates in several different states. You're looking at, again, optimum performance means the pavement condition was chosen correctly. You're putting the right mix at the right time, at the right place. You're looking at an add-on of about 8 to 10 years. The measurement of effectiveness, you're going to try and reduce the moisture going into your pavement. It's kind of a common theme, something that should kind of ring a bell for everything that you're doing and placing on top. So you're going to help alleviate some of the rutting problems, the roughness problems, reduce the oxidation of the underlying layers since you've sealed it off. You're going to help correct some of that if you have low friction spots. If you have problems with areas that have a little bit slick, where you get that really tough aggregate and that friction aggregate and you put it on top of the micro surface, those sections should be cured with this. As far as best practices go, you might make sure that if you do have any larger cracks, go ahead and crack seal them first. So a lot of these treatments can be combined and used together. They don't have to be isolated just by themselves. Make sure the temperature, humidity, etc. Is super important with these treatments because you're dealing with emulsions and that is your primary component in the microsurfacing. You have to be aware of your environment. Make sure that your aggregate is clean. Dusty aggregate, dirty aggregate, it will not stick to the actual asphalt. You'll get that little encapsulation with the water and the dust, the water from the emulsion and the dust from the aggregate, and it just will not stick to it. Make sure you don't have anything growing before you put down your micro because it'll just keep growing through the micro. Just do your due diligence. It's like anything else. Make sure that you have your pesticides out, done. If you have some minor cracking or minor areas that you feel like you can fill with the emulsion before you put the micro down, treat it. Make sure that the vegetation is not going to come back. Roll the parking lots, the cul-de-sacs, and other pavements that do not receive the regular traffic. So just be conscious of those areas. If you're going to do the micro, just make sure that all the areas get hit and properly placed. The last section I had was thin lift overlays. Mike, I know that we're pressed against time. If you want to do the last poll question, you can, just so people can leave if they need to.
Okay, hold on. So which treatment penetrates the top 3/8 of asphalt pavement, reducing the binder viscosity? All right, I got 71%. 92, one more. Thank you. Send polling. Share results. All right, Tanya, can you see that? You want to respond?
Yeah, so your top 3/8 of the pavement, you're looking at rejuvenation. Crack sealing, it doesn't actually rejuvenate. You can penetrate the top 3/8, but you can also go down a little bit farther than that depending on how far you cut. So, but the primary part of that question is reducing binder viscosity. That's the sole purpose for the rejuvenation. So that's kind of what we're looking for. All right.
Very good, thanks.
All right. Very quickly, the thin lift overlays, and some people kind of go back and forth on this as being a preservation treatment, but it actually is. Primarily in Florida, because if you're familiar with the Florida DOT specifications for asphalt, you start looking at that third bullet and it says the thickness between 0.75 inches and 1.5 inches. And we actually have mixes, hot mixes, that fall into that category on a normal basis for a mill and fill. So we start looking at it and they are actually classified as thin lift overlays. The big thing about this one is that you have conventional dense graded mixes, you have open graded mixes. So you think of our Florida's FC5 mix, and the conventional dense grade is the 9.5 millimeter mix. Both of those fall within that thickness range. We do not do stone matrix asphalt in Florida, but a lot of them are also thinner uses as well. Again, we do have, Florida does have a 4.75 millimeter mix that can be laid from a 1/2 inch to 1 inch. So it does qualify as a thin lift. And a lot of times you'll see warm mix asphalts being used with thin lift overlays, primarily because they cool so fast. You don't have a lot of material to maintain that heat, so you got to be conscious of how fast that material or that pavement's going to cool. Make sure you can compact it on time. One example of an ultra-thin bonded friction course that we have in a couple places in Florida, it's a gap graded mixture, the polymer modified binder with a heavy polymer modified tack. So it's one paving train, it's a single pass, and it's all done at once. So your tack, your mix, all get put down at the same time. Your thickness is between 4/10 to 8/10 of an inch, and it is used to address minor surface distresses and a lot of times friction. They have the bonded friction courses, which what we called it. This is an example in Orange County that was laid. You have a very high quality aggregate, again, primarily to get that friction back. It is a gap graded mix, similar to an SMA. Reduces the noise and back spray, so you do get that safety factor in there. But the mix design is special. It's a special process in order to do this. They have a spray paver machine. So the primary thing here is that as you're looking at it, the emulsion goes down and the mix goes down right behind it. So you have no trucks go backing up and moving over the tack coat prior to paving. So that's a big deal. One of the biggest issues of the tack coats is the tracking. We have trucks having to back up to drop the mix into the paver, and you get that tire tracking coming all off of that tack. So with this process, the idea is that that emulsion ends up going down, and it is, as it evaporates, that water pulls some of the emulsion up through the mix and bonds the lower portion of that mix down to the underlying layer. So you're looking at a mix that is filled up about halfway of the layer thickness, and then you're looking at that open structure on top. That's an example of a bonded friction course that was laid over concrete, and it is, I think you get some reflective cracking over time, but overall it has looked very, very good. But the idea here is, it's, again, all at once. You put it in one pass. You finish the striping southbound 1 mile, done in 2 hours. So the thin lift overlays, you're looking at correcting some port friction, some roughness problems, so you can level any of the issues out with any minor rutting, surface defects, and be able to, if you have some bleeding, this will help dry up that bleeding that's underlying it. You're going to seal off that bottom, so you're going to reduce the cracking, the reflective cracking as it comes up, so you can have that polymer modified tack underneath it to try and reduce the reflection of those cracks. You're going to seal all the moisture coming out from the top, and you're going to end up having to prevent some of the raveling that may have previously been present. Negative effects, I don't really know of any. I mean, it's a hot mix. if ideally, when you think about looking at the thin lift overlays, it's just hot mix is just not a lot of it. So we do hot mix all the time. So just a little bit of it should be good as well. When it's done properly and you're looking at using as a really efficient process in order to extend the life, you can still get about 8 to 10 years. But if you have a pavement that is still showing structural integrity issues, you have base failures, you have different types of block cracking, you may want to try to address those first and then come back and do a treatment afterwards. Because if you're just trying to extend it out another 4 to 6 years as a stopgap, you may be paying a little bit extra for this type of mix just to get another 4 to 6 years out of it. So using it right in the right spot, you're looking at about 8 to 10 year life extension. Let's see if overall, the best practices are the same best practices that you would use for hot mix. The biggest deal here is to look at your pavement, your mix temperatures. Be aware of when you have to actually get on it to compact and roll. It cools very quickly due to the smaller quantities. And a lot of people will use that remixer, that shuttle buggy, and some warm mix additives in order to help them get on that properly, get density. The bottom line in any of these treatments, you're looking at proper QC, make sure the quality control as far as your mix designs, your materials, your certifications are all there. Make sure you have pre-construction meetings, go out and see the site. Make sure you have somebody there that understands the process during construction, and looking at the process after it's laid. So the post-construction is just as important as having someone there during. The QC QA, again, remember you have certifications for a lot of these distinct materials. You're looking at emulsions that you may or may not be familiar with. So lean on your suppliers, let them educate you, let them help you understand what that type of emulsion is used for. The aggregates should all be coming from mines that are qualified. You know, make sure that the aggregates are certified. You can get data from the mine. Have the mix designs done that by someone that understands it, you know, or at least have a mix design submitted. I would not go into a lot of these processes without at least asking about the mix design. If someone kind of stares at you and goes, I don't know, it's a mix design. We don't need it. We just always do this. Well, they should know what always is, and they should be able to put it down on paper. Equipment maintenance is just as important, if not more important here than it is with hot mix. Remember that quantity of emulsion getting sprayed is super critical to the success of whether or not that aggregate's going to stick to it. That spray bar on that distributor, maintain it, make sure it is calibrated, make sure that the driver understands the speeds that they need to go in order to get the right spread rate. And overall, here are some just different organizations if you're interested in trying to learn more about pavement preservation. The Florida DOT does have specifications that they worked with in order to, with the Pavement Preservation Council to put together. They just do not use them on the state projects. So I would say that if you're looking to try and gain a lot more information on it, the Florida Pavement Preservation Council is a good place to start.
I just want to add, if nobody knows Chris Evers, you got to meet him. So Chris did a presentation earlier. I think he was technical session number 4. So I appreciate
yeah, Chris is all over the state. He, I'd be surprised if many people on here don't know him. But he has a wealth of knowledge, and I would certainly say to definitely use him. But that is it. 9 minutes over. Sorry.
No, that's about what we had for technical problems there. That was very good. I don't see any other questions. I do have one.
Okay.
In your first couple of slides, you showed the curve, the degradation curve there for the pavement. how do you
sorry.
all, no problem. How do you all go ahead and create that curve? In other words, I'm saying it because I kind of know my answer, but I want other people to know. I mean, do you all use the paver program and such? Or is there no other methods to be able to,
Well,
kind of,
it's a little different for everybody, or as far as I've seen. Creating those curves is a little bit more of a generalized design idea, unless you're tracking very specifically in your system. If you have some way to be able to go and look at your system and look at the average life cycle of your payments and be able to look at, say, okay, it takes me about 4 years to start really seeing that decline, and then kind of get from a good or fair payment down to something that really needs to be addressed. So it's really about understanding and looking at your payment management system to create a curve that is suited for your area, and then being able to come back and look at what the effectiveness of each treatment would be.
yeah, I mean, some roads may deteriorate a lot quicker than others because of traffic volumes and such. And then, of course, construction probably has a factor in how quickly they'll deteriorate also. But
Yeah, and a lot of them that you'll see are relatively generalized, based on averages of the system, unless you're addressing very specific problem.
yeah, I'm a stormwater guy. That's why me and my buddy Gator there, enjoy the water. But I've been through enough of these to know and listen to pavements, and I know it's not something as simple as just going out and looking at the roads. There's a lot more to it. So I'm glad that you all did the presentation. I'm glad that you're involved with APWA, and I encourage you to stay with us and let us know more. I mean, it's definitely something that I deal with some people and they say a lot of money from the municipalities and governments go into pavement. We really need to make sure those people are educated on how to spend that money correctly.
Absolutely. And sometimes it's just about having a person to call. So,
Right. And it's not me, so I can send you some right people, but not me. I'm not a pavement person. So again, thank you all. I appreciate your time. Sorry we went a little bit over. It is recording, so I'll get them. My Dropbox got a little bit larger, so I'm able to start putting them out there, and I'm going to start sending emails off to everybody so they can view them and save them.
all right, and I'll
All
send
right.
you a copy of the presentation.
Excellent.
All right.
Well,
Thank you, everybody, for hanging in there. Let me present.